and I welcome you all on board. And in today's tutorial, we are starting a fresh course, PED114. All right, and this course basically is more of the theoretical part to mathematics. We're going to be talking about a lot of things about mathematics, a little bit of calculations here and there, but it's more of the theoretical part to mathematics, and it promises to be an interesting one. And I believe this is one of the major courses for the Department of Early Childhood Education in 100 level second semester. All right, so I expect you to have your writing material set, and you're expected to take note to our classes ongoing, and forward your note to your respective classes as soon as we are done with each classes. Attend to your assignments as well, as is the metrics for ensuring that you have been following. All right, with this being said, let's hop straight into it. So I have as I'm PED 114, PED 114. Okay, now just like as I said earlier on, we're going to be talking we're going to be talking about how, all right, why do we even study mathematics? Okay, why do we have mathematics cut across a lot of department, faculties, subjects, you know, in tertiary level, in early stages of education and the likes? Why do we have mathematics being considered as very important? All right, we're going to be talking about all this in the class today. So let's first talk about the term mathematics itself. All right, okay, so from what we have here, mathematics is important. All right, it's important and useful for our day-to-day life. All right, mathematics is just is beyond, all right, just arithmetic. All right, mathematics is beyond arithmetics. Mathematics, okay, it's beyond just arithmetic. So we'll be dissecting that in this class. Now, it is useful in our day-to-day life. It is useful in our day-to-day life. Okay? Now, mathematics is the basics for the subjects such as science and engineering. All right? It is the basics. One, two, the basis for, all right, other subjects such as science and, all right, engineering. Is the basics for other subjects such as. Now, it helps basically, all right, a lot of students have been denied, all right, admission some years, all right. Some have to even go back to get it right with mathematics, and you keep wondering, why is it so important anyway? After all, how many of you or how many of us who are graduates, all right, you get to work and you need to solve a simultaneous equation or an algebra equation, all right, or quadratic equation before you are allowed into your office. I mean, or I really don't get, maybe you want to seal a transaction or you want to seal a deal and they needed to ask you the formula, maybe for sets, or the formula for vectors, or maybe a linear equation. Nobody does that. But why? So why is it so important that we are to go through this subject. All right, no department, no all right, one way or the other, you still touch it. Now the basic thing is that the reason why it seems so important and it cuts across of things, all right, to the extent that it is very important in our day-to-day life, is because was it helps us develop logical thinking. All right, it helps to develop logical thinking. All right, it helps develop your logic, your ability to think logically. All right, it does that. It also helps us to find the right way to solve problems. All right, the right way to solve problems. Basically a lot of questions, okay, a lot of challenges mathematics poses, all right, and you have to most time think out of the box. All right, you have to observe processes, you have to observe steps. All right, it's one thing I like so much about mathematics, which is very easy to pass compared to other courses or compared to other subjects, is that one thing with mathematics is that if you are given a problem to solve, all right, you are graded based on steps. All right, your score or your grade is based on steps, meaning that you can even unlike maybe you have to define something now, all right, and you probably did not define it well. All right, it's holistic, you'll be graded based on your holistic definition. All right, but mathematics, you can, maybe a question has 4 steps. All right, you go to the first step, interpreting the question, second step, application of the formula, and the third step is when you now got it, or maybe when you are trying to calculate it, you got it all wrong. The remaining 2 steps you can be marked wrong for that, but for the very first steps, which is just interpreted the question, then also apply the correct formula, you'll be graded for those ones. All right, so mathematics helps us what to solve problem, and before you can solve problem, you have to be able to think logically. It is very, very important. All right, so we have that. Now, memorizing of rules and mechanical manipulations of numbers were considered sufficient. All right, mathematics, under mathematics now we have all right, so mathematics, it helps in what? Memorizing of rule. All right, memorizing of rules, and mechanical manipulation and mechanical manipulation. All right, helps in memorizing rules. All right, but just like we said, science, anything science observes processes, observes procedures. All right, you don't just if it's not observing rules, then it's not science. All right, if you are not observing rules, if you are not observing processes or procedures, then it's not science. All right, so it helps to what? Memorize. It has to become a part of you. Memorize rules, different rules, and what? Mechanical manipulations. Okay, now we have that as that. It also enhances the skills of what? Mastering of ideas and understanding operation. All right, maybe as if your job require you to take some very tactical decision. All right, mathematics has a long way in helping. All right, it helps you understand things very quickly. All right, it helps you grasp, master ideas very fast, very quickly, and helps you understand certain operation. Right, mastery of ideas and and understanding of operations and understanding of operations. Mastering of ideas and understanding of operations. So we have that as that. Now let's proceed. So now the chief value, all right, the chief value of what? Studying mathematics. The chief value of the study of mathematics is that it trains you, all right, in the use of reasoning power. You can't overemphasize the power of reasoning mathematics imbibes. All right, reasoning power. All right, that's the chief, okay, the chief value, the chief value, okay. The chief value of the study of mathematics is the reasoning power. All right, so we have that as that. Now let's proceed. Now, teachers should emphasize thinking and reasoning rather than memory work. All right, teacher should emphasize on thinking and reasoning. Teachers should help students, okay, to think and reason, not cram. All right, not do memory work, cram. All right, rather, when it comes to mathematics, students should be able to think and reason, all right, on how to solve a problem or ways to go around solving a problem. All right, not to memorize or cram the procedures. Okay. Emphasize thinking and reasoning. All right, rather than memory work. All right, so we have that as that. Now, someone said something interesting about mathematics. Someone said something about mathematics. And the person happens to be a Portuguese. Okay? He made a good contribution about the term, about the topic sentence we are discussing. All right? And he happens to be the famous, all right, pedagogue, the famous pedagogue in person of Squills. All right? Squills. Okay? His name is Squills as a school. Squills. All right? And he's a famous pedagogue. All right. So sorry about that. I think that was an issue from the network. Get back now. All right. So now, Squills, the famous pedagogue, now said that mathematics study trains the students. All right. It trains the student in semantic and orderly habits. All right. And the pleasure connected with successful conquering of difficult stimulate willpower. Now the point here is, all right, semantic and orderly habits. It trains whoever is studying it with what? Semantic and orderly habits. Trains in semantic and what? Orderly habits. Trains in semantic and orderly habits. All right, with the pleasure connected with conquering of difficulty. To conquer, all right, to conquer to help. Now, there's a pleasure attached to it, not just to conquer. There's a pleasure after it trains in semantic and orderly habits. Okay, now, and the pleasure, there's a pleasure connected to the study of mathematics that helps you being trained semantically and orderly habits, all right, in order to what? Solve a problem with willpower, willingly. All right, trains in semantic and orderly habits with the pleasure, all right, to conquer, all right, difficulties with what? With willpower. To conquer difficulties with willpower, according to quote the famous pedagogue. All right, and this is what he has to say about, that was his contribution about mathematics. Okay, sorry about that. My student, so I have to let him know I'm in class. Just a moment, I'm just gonna have to quickly let him know I'm in a class so he doesn't keep calling. Okay. Okay, so sorry about that. Just a moment. Now, let's proceed. So, having spoken about what Quiz said, now let's proceed. Now, mathematics makes constant demand upon imagination. That is according to Prakash in 2011. Prakash in 2011. He said there's a constant demand. All right, there's a constant. A demand is hereby constant, and that demand, which is a constant one, is what? The demand upon imagination. All right, the demand upon imagination, all right, when it comes to mathematics, the demand upon imagination is constant in what? In mathematics. So we have that as that. All right, now, so very quickly, let's just say a thing or two about, all right, the benefit, or should we say the reasons, or what you, all right, the benefit, yeah, more of the benefits of studying mathematics. All right, so we have who is this person again? So we have that is that. All right, the study of mathematics. Just a moment. So, the study of mathematics, all right, helps with the ability to conceptualize, inquire, reason, and communicate mathematically, and use mathematics to formulate, all right, and solve problems in daily life as well as in mathematical context. Okay, now let me take that again. All right, now the ability to what? Conceptualize, inquire. All right? Ability to conceptualize, all right, inquire, all right, reason and communicate. Reason and communicate, all right, mathematically, and how to use this mathematics to solve problems in your day-to-day life. All right. Now, the ability to what? Manipulate numbers, symbols, and other mathematical objects. All right. To manipulate what? Numbers. All right. Symbols and other mathematical objects. Objects, okay, OBJs. All right. Now we also have the number sense, symbol sense, spatial sense, all right, and a sense of measurement, as well as the capacity or the capability in appreciating structures and patterns. Different types of senses, all right. The number sense, symbol sense, spatial sense, measurement sense, and structure and pattern sense. All right, number, series of senses. We have number, we have spatial, we have number, we have spatial, okay, sense. Number, we have spatial, we have symbols. We use that a lot in logic reasoning. All right, symbols, numbers, spatial, all right, and appreciate what? Structures and patterns. All right, patterns and structures. Appreciate patterns and structures. All right, and we have that as that. It also gives you a positive attitude towards mathematics and capacity to appreciate aesthetic nature and cultural aspects. All right, so we have that as that. Now the main goal, all right, the main goal of teaching mathematics, all right, the main goals, there are some certain goals that are eccentric, all right, that they are germane, all right, that they are important in the teaching of mathematics. Okay, now let's look at these goals. It's quite windy outstairs today. It's quite windy, and I think we can hear somehow the noise from the noise of the background. Right. Okay, so we have so I windy today. Okay, so we have main goals. Okay, now what are the main goals? Now, okay, the main goals of teaching mathematics at primary level. Here is our primary level, age 6 to 12 years. Age 6 to 12 years. All right. Primary goals. They have basic skill in numeracy. Basic skills in numeracy. Okay. Basic skills in numeracy. All right. That's 6 to 12 years. That's a basic skills in what? Numeracy. All right. It introduces them to basic skills in numeracy. It also enhances the ability to what? The skills, solve problem, to what? Solve problems. All right. So we also have the ability to what? Estimate and make or calculate approximations. All right. Calculations and approximations. Approximate slash calculation skills or ability. All right. The basic skills here. Okay. And we also have the ability to interpret the interpretations of graphs and arrangement of numerical data. All right, graphs and arrangement of numerical data, pie chart, bar charts, all these numerical data. All right, they are introduced to these four things. All right. Now, the revised version, all right, or the edition. Okay, I think I can erase this so we can have space. Now, the revised edition, okay, of the National Mathematics Curriculum, all right, for the basic education program, beginning from basic 1 to 9, all right. In this new curriculum, there is no primary mathematics curriculum for junior secondary curriculum, all right. Now, the primaries 1 to 6, all right, the primaries 1 to 6, GS 1 to 3 have been infused into what? Basic 1 to 9. Now, let's put this down. Now, in the revised edition of, we have revised edition of what? The National Mathematics Curriculum. That's National Mathematics Curriculum, NMC. All right, is for the what? Basic education program beginning. Right? Basic educational program. Basic education program. All right, from basic 1 to 9. From basic 1 to 9. All right, now it's been revised, okay, from basic 1 to 9. Then there is a new edition, and in this new curriculum, all right, primary mathematics curriculum for GSC, that is the junior curriculum secondary, has been extracted. All right, it has been removed. All right, extracted. All right, PMC, that's the primary mathematics curriculum, PMC, extracted PMC, all right, in the new curriculum. There is no PMC for GSC, PMC, extracted PSC for junior, all right, junior what? Secondary curriculum. All right, so in the new, okay, in the new curriculum, this is double R, curriculum, in the new curriculum, all right, PMC has been extracted. PMC for GSC, all right, that is the primary mathematics curriculum for junior secondary curriculum, has been extracted in the new one. All right, so now the thing is now that the primaries, which is 1 to 6 and GS 1 to 3, that's primary 1 to 6 and JSS, all right, JS 1 to 3, all right, have been infused into what we now call basic 1 to 9. Basic 1 to 9, all right, has been infused in basic 1 to 9, all right. Now let's take a note of this point. The universal basic education, which is UBE, universal, all right, basic education, all right, universal basic education, all right, bill of 2004, all right, bill of mandated a 9-year compulsory education, all right, mandated a 9 years compulsory education, all right, the universal basic education mandated a 9 years compulsory education. So we have that as that, and on this note, call it a wrap for today because we are a bit okay, let's see one or two things. Okay, let's quickly take this before we call it a wrap. Now we have very quickly, let me quickly walk us through this. Now, the revised national mathematics curriculum for basic education in Nigeria, right? Revised national mathematics curriculum, all right, for basic education in Nigeria, all right, in Nigeria is particular about giving children, one, acquire mathematical literacy, okay, one, at children, all right, it's particular about giving children, all right, the opportunity to what? Acquire mathematical literacy. One, acquire mathematical what? Literacy. All right, acquire mathematical literacy. All right, cultivate the understanding and the application of mathematics skills. Understanding and the application. It's not good enough to understand, but you have to also applicate. Application. Applicate. Yeah, I think that was a mistake. Application of what? Mathematical skills. Of math skills. All right. In this, all right, ever-changing technological world, okay, to develop essential elements of problem solving, communication, reasoning, now that's dev, all right, problem solving attitude, problem solving attitude, all right, problem solving attitudes. Also understand the major idea of mathematics, bearing in mind that the word has changed and it's changing now. We have that as major idea, understanding the major idea, understanding the major, the concept itself of mathematics. Okay, so we have that as that. And we also know, please take note of this point, that the National Mathematics Curriculum was developed in the year, that is the National Mathematics Curriculum, developed in the year 1977. Okay, let's take note of that point. So now we should also know that there's an approach called the thematic. There's an approach called the thematic approach, and this approach, all right, was developed in order to what? Select content and learning experience in the curriculum. Content and learning experience in where? In the curriculum. Okay, and we have that as that. And on this note, call it a wrap for today. And in our next class, we will continue from just where we stopped. All right, so on this note, I want to say a big thank you to each and every one of us, for many of us that joined early, and for those that joined a bit late. All right, thank you very much everyone that is on the stream, and I look forward to seeing you in subsequent tutorials. I remain your tutor Ayo, and let's do well to bring our notes up to date, submit our notes, and let's bring them up to date. And I look forward to seeing you in subsequent tutorials. Have a wonderful day.